Welcome to The Explainer. Today, we're popping the hood on this massive AI boom to uncover a physical hardware constraint that is quietly dictating the pace of the entire tech industry. We hear so much about algorithms and software taking over the world, but right now, it's actually a critical supply and demand imbalance, specifically the semiconductor memory crunch that is completely running the show for AI advancement. So, why are the world's most powerful AI chips just sitting idle? It sounds totally counterintuitive, right? Companies are dropping literal billions to get their hands on the most cutting-edge AI processors out there. These chips have compute cores that run at blistering, almost incomprehensible speeds. And yet, despite having these incredibly fast engines, our multi-million-dollar AI processors are practically starving for data. They're just sitting there, powered up, ready to crunch the numbers, but they're stuck waiting. Why? Because the data they desperately need to process just isn't arriving fast enough. To really wrap our heads around why this happens, we have to talk about a concept known as the memory wall. This is the physical bottleneck that keeps these super powerful chips from hitting their peak speeds. Imagine having the world's fastest chef in a kitchen, a chef who can chop vegetables at the speed of light. But for every single carrot or onion, that chef has to walk all the way out to a grocery store down the street. Suddenly, the chef's chopping speed doesn't matter at all, does it? The walking time is the bottleneck. Well, in the AI world, the processor is our fast chef, and the memory wall is that frustratingly slow walk to get the data. It absolutely does not matter how fast the processor computes if the data delivery is stuck in traffic. Let's shrink down to the microscopic level for a second to see the root of the issue. Almost all modern AI systems are built on the classic von Neumann architecture. This is a design where the processing unit and the memory storage are kept completely separate on the circuit board. Because they're physically apart, data has to be constantly fetched across a connection, computed, and then written back. Now, keep in mind that modern AI models involve billions, sometimes trillions of parameters. That means the processor has to make this microscopic commute billions of times a second just to fetch the data it needs. So what's the fix? Well, look at standard memory versus high bandwidth memory, or HBM. Standard memory is kind of like a narrow, two-lane rural road. It relies on standard data buses that just cannot handle the massive, heavy-duty data volumes required by modern AI. On the flip side, we have HBM, which is the industry's answer. HBM is essentially a multi-level superhighway. It literally uses 3D stacked memory dies, stacking chips on top of each other, with each layer often thinner than a human hair, and connects them with these vertical pathways. This allows for insanely dense and fast data transfer. But, as you can probably guess, building a microscopic 3D superhighway is incredibly difficult and wildly expensive. And here is the kicker. Even when we know how to build these HBM superhighways, we slam into a whole new set of physical manufacturing roadblocks. First up is advanced packaging. You can't just snap these parts together like Legos. The complex assembly of HBM right next to the GPUs requires highly specialized techniques, which creates huge secondary delays in the supply chain. Second, we've got major energy constraints. Physically moving this massive amount of data across the chip generates enough heat to double as a space heater, and it drains a fortune in electricity. And third, to actually make this specialized memory, manufacturers are having to scramble and shift their standard memory factory lines just to try and keep pace with AI demands. Let's zoom out to the global supply chain, because the imbalance here is just staggering. A massive 85% of high-bandwidth memory consumption is being swallowed whole by the hyperscalers. We're talking tech giants like Google, Microsoft, Meta, and Amazon. They are essentially hoarding the limited supply of this highly specialized memory, often locking down factory capacity years in advance. That leaves a measly 15% for the entire rest of the market. So if you're a smaller tech company or a startup trying to build out some AI infrastructure, yeah, you are basically fighting over scraps. Because so much manufacturing capacity is diverted to feed those hyperscalers, we are seeing a massive domino effect rippling through the entire global economy. Look at this table. In AI data centers, throttle performance is becoming the absolute norm as those incredibly expensive GPUs sit idle. Over in the enterprise market, IT leaders are suddenly dealing with sky-high prices and massive lead times just to get standard server memory for their basic day-to-day operations. And yes, this hits you directly too. Over in consumer electronics, because those factors are retooled for AI, the cost for memory components in PCs and smartphones shoots up. It literally jacks up the price of the smartphone in your pocket and leaves you with fewer high-memory options. This bottleneck is driving a fundamental paradigm shift in computing right now. Just look at this quote. Minimizing data movement is now as important as raw computing speed. Think about that for a second. For decades, the entire tech sector was absolutely obsessed with peak computing speed, how many theoretical calculations a chip could pull off in a single second. But this memory wall is forcing engineers to completely rethink that. Today, the priority is what we call delivered performance. This actually measures how well a system handles real-world memory-bound tasks. Because let's be real, it doesn't matter how much horsepower the engine has if the transmission can't get that power to the wheels.
Okay, so how on earth is the industry trying to fix this crisis and break through the wall? Well, they're attacking it in three main ways. First, architecture redesign. Instead of constantly moving data to the processor, they're shifting to compute-in-memory designs. This means they actually process the data right where it lives, completely cutting out that microscopic commute. Second, companies are relying on strategic allocation, basically locking in massive long-term contracts so their supply doesn't run dry. And third, vertical integration. Instead of buying standard off-the-shelf parts, AI companies are partnering directly with memory producers to build custom memory stacks that are hyper-optimized for their specific AI models. But hey, it's not all just a hardware game. Software developers aren't just sitting around twiddling their thumbs waiting for hardware fixes. They are aggressively shrinking the AI models themselves. Basically, if you can't widen the highway, you have to make the cars smaller. They're doing this through a technique called model quantization, which slightly reduces the mathematical precision of the models to drastically shrink their overall file size. They're also using a really cool trick called pruning, where they literally chop out unnecessary parameters from the neural network. This makes the models far less memory intensive and ensures we can scale up these AI workloads without just blowing up our hardware and energy costs.
While those hardware and software solutions definitely sound promising, we have to talk about the terrifying structural risk of the market itself. We are staring down a massive single point of failure. Right now, a very, very small number of memory manufacturers completely dominate the high bandwidth memory market. The entire global AI ecosystem is balancing on the shoulders of just a handful of specialized suppliers. This creates some serious technological uncertainty. I mean, think about it. If a single manufacturing facility goes offline, or if smaller businesses get completely priced out, the entire momentum of the global AI industry could literally hit a brick wall overnight. So when does this ease up? Well, 2027 is the year you really need to keep in mind. You see, building new semiconductor fabrication plants, those massive ultra-clean factories you need to build 3D memory chips, takes years of lead time and billions upon billions of dollars in capital. Because of this massive lag between the sky-high demand and the physical reality of construction, industry experts are predicting this crippling supply shortage is going to persist until at least the year 2027. So buckle up, because we are in this bottleneck for the long haul. As billions of dollars desperately flow into unproven compute-in-memory technologies just trying to solve this crunch, I want to leave you with this final thought to chew on for today's explainer. Are we betting on the right architecture, or are we just building bridges to nowhere? These near-memory technologies are still evolving so incredibly fast, and a miscalculation by these tech giants betting on the wrong architectural shift could lead to billions in stranded investments. The memory wall really is the most critical hurdle in modern computing, and how we choose to climb it is going to dictate the entire future of artificial intelligence. Thanks so much for joining me on this deep dive, and remember, keep your eyes on the hardware. That is where the real revolution is happening.